In path representation method, I can count by actually representing the possible paths. For example, there is a town, say A, there is another town B, and there is another town C. The question is follows: if I were to go from A to B, I have three possible options that I can take for going from A to B, and from B to C I have two possible options. Then the question is, in how many ways can I go from A to C? So that is very easy. It uses multiplication principle, that is 3 into 2 equal to 6, but I want to really count all the possible ways and prove that it is actually 6. So how can we count it? Let us first start with naming the possible paths that we have here. So let me name this as P1, let me name this path as P2, let me name this path as P3, let me name this path as W1, and let me name this path as W2. So what I can do is, once I will choose one path, I will choose the first path here, that is P1, and I will choose the second path here, that is W1. So it is one of the possibilities that I can have. Then without changing this path, that is the first variable P1, without changing this, I will try to look for other alternatives. I have kept this the same here and I am looking for any other alternatives. So the next alternative coming here is W2. So P1 W2 is another path, and I do not have any more alternatives here, so I will now switch to the next variable. So once I have exhausted all the alternatives in this case, I will switch to the next variable. Here the next variable is P2, and with P2 I will go with the first variable of this side, that is W1, and keeping this P2 as the same, I will switch to the next variable, that is W2. So this is the fourth part, and I have exhausted all the paths after this. So now I will switch to the third variable of this side, that is ABP3, and after choosing P3 I can choose W1, or once I have done this I can choose P3 W2. So these are all the 6 possibilities that I can have, and this is one of the most basic cases of path representation method, and it finds direct application in solving questions regarding how many ways are there to go from one place to another via some place. So like that questions we can solve very easily using this, but generally the questions ask numbers, and the numbers can be dealt very easily using multiplication principle. Since these are independent events, I can choose any one out of these 3. So I have 3 possibilities here and I have 2 possibilities here. Since these are independent events, they will get multiplied to give 6. But I want to just show that how can we derive all the 3. The basic rule that we have followed here is that we have to keep one path constant and we have to exhaust other alternatives in the second path. That is, I have kept P1 constant. In this case I have exhausted all the possibilities in the second option, that is B, from going from B to C. Once I have chose W1, once I have chose W2, and if there would be another option W3, then I will also choose W3 here. And once I have exhausted all the options in this side, then I will switch to the second option. Like this, if I continue, then I can get the answer. And this method finds application in another problem also, that is suppose we want to find the terms when the 2 or more polynomials are multiplied together. It is very easy to check it out. For example, I want to take an example, that is x cube plus 2x square plus 3 multiplied by x to the power 4 plus 5x square plus 3x plus 1 multiplied by 7x plus 5. So I want to find the number of or each of the terms in this expansion. See, all of them are plus signs. So once I find the terms and just add them up, so I will get the resultant product. The methodology of solving this question is that we will draw some diagrams that were quite frequented when we solve problems of sets. We will represent these terms in this diagram. X cube I have written here, then I have written 2x square, then I have written here 3. Then I will do the same, x to the power 4, 5x square, 3x, then 1. Then here the same, 7x, 5. Now using the path representation method I will solve the questions. So the logic remains the same, keep one the same and alter the other. Here what I will do is I can choose these two, then keeping this as the same I can choose this one. So I get 4 plus 3 7, 7 plus 1 8, 7x to the power 8. Then I can, keeping this one as the same, I can choose this path, that is 5x to the power 7. Then I have exhausted all the alternatives in this case, so I will switch to the next option. Next option is to go for this, and after this I can choose this path or this path. First if I choose this path, then 3 plus 2 5, 5 plus 1 6, and 7 5 is 35, 35 x to the power 6. Yeah, and now this path is already done. I have to choose the second path. So this is the second path, that is 25 x to the power 5. Yes, so this is also done. And now see, these options are exhausted. I will switch to the next option. Next option is to go with this one, and with this I can combine with this term or this term. If I combine it with this term, then I shall get 7 3 is 21, and then x square x to the power 5. Then if I combine with this term, then I will get 7 3 is 5 3 is 15, then 15 x to the power 4. Yes, so I have got this one. Then these alternatives are again exhausted. I will switch to the next alternative, that is this. Can combine it with this path, that is x to the power 1, and then I can choose this one, that is x 7 x to the power 4, or I can choose this, that is 5x cube. Now see, all these alternatives are again exhausted. So after this I have to choose from this path, and I have to go here, then I have to choose from this path to go here, then again I have to follow the same thing and I have to exhaust these options also, and after that I will get the terms of my required expansion. So this process seems to be too lengthy, but the basic funda or the basic property is used in binomial theorem. So if I say that I want the expansion of x plus a to the power n, so what it basically says is that x plus a multiplied by x plus a multiplied by x plus a, it will be continued till n times. So that is the main logic that we have to take. It will be continued n times. Now how do they derive? Let me show the derivation. The derivation comes from the path representation method. They will write here a like this, x a like this. They will continue till the n times. It will happen n times. Now how do they derive it is that, see, when I will connect this, after connecting long, then I can connect it with this option, then I can connect it with this, and there will be several options. So they first do it that the leading coefficient or the maximum coefficient that I can get is by combining all the x's. So there are a total of n times. So if I multiply x n times, so that will be x to the power n. And now they see that in how many ways can I choose all the x's from here. That is, in how many ways can I make x to the power n? In one way, because there is only one possibility that I can take. I can take only from here I can take x. So only I have one possibility, and by taking only x from all of them, only then can I get x to the power n. So that is sorted. But when I move to the next term, that is if I decrease the coefficient, that is I want to choose n minus 1 x's, and if I multiply them I will get x to the power n minus 1, and then 1a will be left out, so a. Now the problem here is that I have to choose 1a. In how many ways can I choose 1a? There are a total of n alternatives, as I can see. From n alternatives I have to choose only 1a. So the required coefficient will be nc1. Now if I move further, x to the power n minus 2 into a square, I have to choose 2a from this whole. So there are a total of n, and I have to choose 2, so nc2, and like this way it will continue. And one more application that we are confronted with is that to solve the questions of devices. If we want to find the number of devices, this method is too helpful. number of devices, not if we want to find the exact devices. First, to find any divisor, we have to first do the prime factorization of that number. Only then can we find the devices. For example, if I have 100, say I have a number 100 and I want to find all the devisors of this number 100. So the method that I adopt is that first I have to do the prime factorization. So if I do the prime factorization of 100, I do not need to do it. I can only tell that it is 10 square. So 10 is 2 into 5 whole square. So it is 2 square into 5 square. Done. So this is the prime factorization of 100. Now it is the most important thing that I am going to tell of path representation method. That is, if we want to find the divisors, then what we will do is that here the leading coefficient of 2 or the maximum or the coefficient or the power of 2 is 2. So 2 to the power 2 and the power of 5 is also 2. So by starting from 0, we will reach that power. Like here it is raised, the base is 2. We will start from 0, 2 to the power 0, 2 to the power 1 and 2 to the power 2. We will move to the power which is present here from 0 to that power. Similarly for 5, we can do it 5 from, we will start from 0 and then we will move to that power. Now after doing this, we will simply combine. What I get here, 2 1, 2 to the power 0 into 5 to the power 0 equal to 1. Then here what I get, 5, 25, 2, 10, then here 25 to the 50, then 4, then 4 5 the 20, then 100. So how many do I get? 1 2 3 4 5 6 7 8 9. So we get total 9 devices, and I also know the individual devices. So that's it as answer. And the shortcut is that we have to extend, means we have to increase the power by 1, 2 plus 1, and we have to multiply the individual. 2 plus 1 into 2 plus 1 equal to 3 and multiply it by 3, so that is 9. 9 is our required answer, and we can state it combinatorically that we have 3 options, we have to choose only one. So there are 3 possibilities here and there are also 3 possibilities here, so answer will be 9. That is total number of devices. But if I want to find the individual devisors, then I have to adopt this method. That is, I have to first combine all these terms like here, then I can only find the devices. Let me take another example to illustrate this fact. Suppose I have 80. I want to find the devices of 80. So I have to do the prime factorization. So if I divide it by 2, then I will get 40, 20, 10, 2, 5. So 80 can be written as 2 to the power 4 into 5 to the power 1. So what I will do is that I will start from 0 and move to 4. 0, 1, 2, 3, 4. And similarly for 5, I will start from 0, move to this point. Now I will simply combine 1, 5, 2, 10, 4, 20, 8, 40, 16, 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In total we have 10 devices, and I also know the individual devices that I have got. So that was all about the part representation method. In the table method, we have to draw the table and we have to increase or decrease the value of the variables so as to satisfy the given condition. Let me take an example. If we are given this question, x plus y plus z is equal to 10, where x, y and z belongs to the set of whole numbers, that is natural number including 0. So it belongs to the set of whole numbers. We have to find the possible combinations of x, y and z, and we have to answer this question. So how we can proceed is that we have to draw the table x, y and z like this. And once we draw the table, we have to first assume the least value of one variable, and then we have to increase or decrease accordingly. So since this belongs to the set of natural numbers, the least value that it can take is 0. I am assuming x to be 0. Then since y also belongs to the set of natural numbers, natural numbers including 0, so it can also take the least value as 0. Now I will alter this value. So in this equation, if we put x equal to 0 and y equal to 0, so z turns out to be 10. So it is one option. Then I will increase this value of y, keeping the value of x as fixed. The next value that it can take is 1, and accordingly z will take the value of 9. So keeping x fixed, I will keep on doing this thing until I get my condition satisfied. So if I keep it to be 0, then it turns out to be 8. If I keep it to be 3, then 7. If I keep it to be 4, then 6. If I keep it to be 5, then it will take the value of 5. If I keep it to be 6, then 4. If I keep it to be 7, then 3. If I keep it to be 8, then 2. If I keep it to be 9, then 1. If I keep it to be 10, then 0. So that was one set. We have completed altering the values of z and y. See, it has reached its 0 state. It cannot go to negative because we are limited to whole number set. And now what we will do is we will alter x. Now we will increase x. First keep z as 0, then we will solve accordingly. Now keeping x as fixed, I have fixed the value of x at 1. Now I will increase the y and z component, means y and z value so as to get the desired results. So see, I am keeping this as 1 constant. Here I have kept as 0 constant, and I have altered the values of y and z by increasing or decreasing successively so as to get the results. Now here also I will keep it as 1 constant, then I will increase or decrease successively so that I can get the results. Okay, 2, then 7, and now it will continue forever and until it is getting exhausted. So the last step I am telling, if I take x to be 8, then if I assume it to be 0, then it will be 2. Then what I will do is I will increase the value of y, then it will be 1, and this combination. And if I take to be 9, then 9, then 1, and 9, 1, 0, and it will end with like this 10, 0, 0. The last step will be 10, 0, 0. Now if I were to solve this equation, that is x plus y is less than or equal to 9, where the value of x must be greater than or equal to 0, and the value of y must be also greater than or equal to 0, and they all belong to the set of integers, or in this case it will be whole numbers. So if I want to find the required combinations, what I will do is I will make a table and I will give the minimum value possible. The minimum value is 0. I will keep it 0, and I will satisfy the condition, that is if it should be less than 9, so y should be less than 9. So the possible values that y can take is less than 9, less than or equal to 9. It can be 9, it can be 8, 7, 6, 5, 4, 3, 2, 1, and it can also be 0. 0 is also less than 9, and the minimum value is 0, so we have reached this minimum state. It is done. Now if it is 1, then y can be less than or equal to 8, so it can take 8, 7, 6, 5, 4, 3, 2, 1, 0. We have reached the minimum state. Now like this we have to proceed. I am showing you the last step. If x is 8, then y can be 1 or 0, and if x is 9, then y has to be 0. So that is our required answer. So once you will solve all these steps, you can get how this is coming. So this question is an extended version of path representation method, but we will not solve it using path representation method because it will be too lengthy. I will solve it using the table method. So first let me draw the diagram to just visualize the coefficients that we are asked. So this is our required diagram, right? And how can I get the coefficients? By combining these powers like this. If I take and just simply combine, then after combination I will get 1 coefficients, and total how many combinations I can do, that will be the number of coefficient, that will be the coefficient of x to the power 9. So I want to imagine that I want to create 9, and total how many combinations I can do so as to create 9. First combination is that I will take all 1 and 1 9 I will take here, that is x to the power 9. In all this case I will take 1 and here 1 9. So if I take only one term, that is one x term, if I say it like this, that I have taken only one x term, that is x to the power 9, and the rest ones I have taken, so the coefficient will be, if I take only one x term, then the coefficient will be 1. Now I want to see what will happen if I take two x terms, and using two x terms I want to create 9. So it can be stated like that: 8 plus 1, that is x to the power 8 into x equal to x to the power 9. Then 7 plus 2, like that it can be done. So if I want to show this formally in path representation, in table method, then I will do it like this: a plus b equal to 9, and I cannot take the value of a and b to be 0, it must be greater than or equal to 1, because the coefficient of x to the power 0 is 1, and I am dealing with only x terms, I am not dealing with the constant terms. See, here I have taken 1 means only one x term I have chosen, that is x to the power 9, and the rest 1. So I am not dealing with ones in this example also, I am choosing only x. If I choose 1 x to the power 8, 1 x, and the rest all ones, my job will be done. So I want to choose two x terms, and the power must be greater than or equal to 1, else it will not make any sense. So if I make a table and do this, and then I can get my desired values. Now one more trick that we need to keep in our mind for solving questions is that in this table method, when we do not want ordered pairs, then we have to assume another inequality, that is a less than b. That is, in this case we have two variables, so a less than b. I have assumed it in this case because I do not want any repetition, because sometimes can be, then I am showing it by illustrating. First of all, I have to assume the minimum value to be 1, and if I put this in this equation, then b comes out to be 8. Done. Then I will increase this value and I will decrease this value. Then I will again increase, decrease, 6 3 9 9, increase, decrease. Now in the second step, if I choose 5 for example, then I have to choose here 4. But see, these two terms are same. If a and b, I have just given it the name, but order is not dependent in this case, order is immaterial. So these two variables are same, and if I put here 6, then this one will be 3. So these two are same. So I am getting repeated results, and to avoid getting repeated results, I have to assume this inequality. And if I assume this inequality, these two terms will automatically get cancelled, because 4 is not greater than 5. And once I get cancelled these two results, I get total number of 4 possibilities. So if I choose 2x terms, then the total number of possibilities is 4. So here the total coefficient will be 4, and here I also have 1. Now let me proceed. If I take 3x terms, then what will happen? That is, a plus b plus c is equal to 9, and again a, b, c is greater than or equal to 1, and I will assume this inequality so as to avoid any repetitions in my results. Now I shall make the table. Start with a. The minimum value it has to take is 1. Then b must be greater than a, so the minimum value of b must be greater than 1, that is 2. And c must satisfy this equation, because it is a 3 variable equation, 1 plus 2 3. So 3 plus 6 is 9. So that is the required coefficient. Now again I will increase it and I will decrease it. I will increase it and I will decrease it. 4 plus 4. See, now these two are equal, and even if these two are equal, I cannot get to equal terms. See, because these are the powers of x, and all this, and in this series the powers of x are distinct numbers. They are not the same. If I have x square here, I cannot have x square in any other terms. So since the powers of x are distinct, so I cannot get this result. I am automatically cancelling it. So I get here only 2 possibilities. Sorry, I cannot conclude. I have to proceed again to confirm that. And if I count this down to 5, then it will be 3. So this inequality will not be true, so I am not proceeding. I am simply putting here 2, increasing this a term. So if I put here 2, it should be 3, and then 3 plus 2 5. 3 plus 2 5, 5 plus 4 9. So this is one more possibility that I am getting. Then 2 4 3, this is not true, this cannot be. Then I can get 3 4, 3 plus 4 7, 7 plus 2 9, this also I cannot take. So total of 3 I can get. So by taking 3x's or by choosing 3x, I can tell that the coefficient is 3. Now if I choose 4, what will happen? A plus B plus C plus D must be equal to 9. So it must be 1 2 3. 1 plus 2 3 plus 2 5, 5 plus 1 6, 6 3. Yes, and it cannot be true because we get here the same terms, and the same terms cannot be the powers that is I have previously told. That is why here we will not get anything. So the answer will be 4 plus 3 7 plus 1 8, and 8 will be the required coefficient, and that is how we solve this question. Now I am going to discuss Punnet Square method. This method is very frequently used in biology, especially in the chapter heredity, but it is not different from path representation method, just that they have made our tasks more easier. It basically states that if we have two sets A and B, then the cross product or the Cartesian product of the two sets A and B can be found very easily using the Punnet Square method. Let me state how it is done. Let us assume that the set A consists of elements x1, x2 and x3, and set B consists of elements y1, y2 and y3. So the way we do Cartesian product is that, or the methodology or the statement of Punnet Square is that, write the elements of one set here in this direction x1, x2, x3, and write the elements of this set in this direction y1, y2, y3. Now simply combine x1 comma y1, x2 comma y1, x3 comma y1, x1 comma y2, x2 comma y2, x3 comma y2, then x1 comma y3, x2 comma y3, then x3 comma y3. By this square method we can very easily calculate the results, and it is said to be a square, but it is not necessarily that every time it has to be the square. It can be a rectangle. For example, if I had one more element y4, then I could write here y4 and do the calculations accordingly. Now notice that it is not a square, it is a rectangle, but still we can proceed using the same methodology. It is generally used in biology, and in biology we generally have squares. That is why it is named as Punnet Square. Let me for example tell that if in Mendel's experiment, let me take the example of dihybrid cross. It is most useful to explain this concept. When we take the example of dihybrid cross, yes, so in that case what we do is that, okay, before stating dihybrid cross, let me also state the application in which this is used in maths. In maths, to find probability, in the chapter probability, when we toss two dice, the total number of possible outcomes can also be calculated using this method. If I state it using the path representation method, we have 6 possible outcomes for 1, 2 3 4 5 6. These are the possible outcomes in one throw, and in the second throw these are the possible outcomes. So if we combine these results, we can combine this using the path representation method that I have already discussed, but it is more convenient to combine this using this table, because using this table we can combine it very easily by writing 1 2 3 4 5 6 in this direction and 1 2 3 4 5 6 in this direction. We can very easily combine all the results and we can tell which result will come when. Now let me explain how the dihybrid cross is done. So one parent generation is taken, that is, in parent generation we have round yellow, this is the representation, and we have wrinkled green, this is the representation. Here the gamete, this will come, and here the gamete, this will come. Now they will mix to form this. Now when it will be self-breeded, this one is F1 generation, when it will be self-breeded, then we have to predict in F2 generation what will come. So in F2 generation the thing that will come is that first we have to identify the gametes. So for identifying the gametes, we have to perform this Punnet Square, that is from R, capital R small r and capital Y small I. We have to find the crosses. That's a Cartesian product, R capital Y small y. So we get capital R capital Y and small r capital Y, capital R small y, small r small y. So these are the possibilities, and then what we will do is we will write all these possibilities in this direction, R, Ry, Ry, yes, and we will also write this in this direction also. Then after writing all these results, we will simply arrange all them side by side, and then we can get our answer. So this is as simple as that. By the way, the method that I have shown here is the cross of A cross B cross A cross B, because if I take set A to be R capital R comma small r, and if I take set B to be capital Y comma small y, first I have done this cross, and after that I have taken these elements and done their cross. So I have done in total cross of 4 sets, and I can also generalize this. Let me take another example, that if I do the cross of 3 sets, then the method of doing that is that first I will draw the cross of these 2 sets, then I will write the elements in this line and the elements of C in this line, then I will perform the crosses in the rectangle, and the rectangle will give me the required answers. And if I say have 5 elements, first I will do the cross of this, then with that I can do the cross of this, then with that I can do the cross of this, then with that I can do the cross of this, and like that by doing crosses I can find out. Or you can also use the path representation method as per the convenience. Now I am going to tell how we can calculate the exact permutations of a given set. Many of us know the formula of permutation and combination, but they do not know how we can exactly find it out. So that is the thing that I am going to tell. First, let me tell the formula. Everyone knows this, but still I am telling. The formula is as follows: NPR is n factorial by n minus r factorial, and NCR is n factorial by r factorial into n minus r factorial. It is the basic formula. If repetitions are there, and in other cases the formula might change. So let me explain how we can calculate the exact numbers. That is, if I have a set, say ABC, what are its possible permutations taking 3 elements, that is all the elements at the time. So total will be 3 factorial, but if I want to calculate all of them, so what I will do is, the methodology is that I have to first take the first element and I have to swap it. It is the first element of the set. I have to swap it with the other elements. Then if I swap A with A, then I will get ABC. If I swap A with B, then I will get BAC. And if I swap A with C, then I will get CBA. So this I get after swapping. So after swapping, what I will do is that I will fix the first elements, and after fixing the first elements, I will swap the second elements. I can swap B with B, so I will get ABC, or I can swap B with C, I will get ACB. Then I can swap, B is fixed, I can swap A with A, or I can swap A with C. Then C is fixed here, I can swap B with B, or I can swap B with A. So these are my required permutations. Okay, after the second step, we will first lock these 2 digits. Now after locking C, only 1 digit is left, so we have no other alternatives to swap. We can only swap it with itself. So since this is our final result, so these are the permutations, and if we count 1, 2, 3, 4, 5, 6, so we get total 6 permutations as the answer. If we want to find the 2-digit combinations of ABC, then it will be AB, BC and CA. In combination, the order does not matter. Order is immaterial, but in permutation, the order really matters. It is very easy for 3-digit variables, that is ABC, but if we have a larger string, that is ABCDE, then it might be difficult. There are mainly 2 ways of doing it. First of all is the geometric method. In the geometric method it states that 1, 2, 3, 4, 5 we have to construct a polygon whose number of sides is equal to, or the number of vertices is equal to the number of variables 1, 2, 3, 4, 5. So we have to construct a pentagon, and we have to name these sides as name these vertices as A, B, C, D and E. Now the number of 2-digit combinations is equal to the number of line segments that we see here. So if I want to complete this figure and include all the given line segments, or all the line segments that I can draw, then 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So total we will get 10 answers, and I can also write them down as A, B, B, C, C, D, and hope you can write them all, because by just joining the line segments, by just seeing the origin of this line segments, we can write all the results. So this was one method. And another method is that it is the algebraic method. Sometimes we may miss out counting the triangles or counting the lines, then we prefer algebraic method. Algebraic method is that we will change this ABCD into A1, A2, A3, A4, A5 just to include some numbers in it. Now what we will do it, we want the 2-digit permutations. So if we want 2-digit permutations, then we have to choose AX and AY. So 2-digit permutations AX and AY, and the condition is that X must be less than Y. It must be strictly less than Y, and Y can be equal to, total number is 5, and X must be greater than or equal to 1. So if we solve this inequality using the table method, then we will get the answer. So let me solve it. How we did it, we first assume the minimum value is 1 here, and we will change it. It must be greater than 1, so it will be 2, it can be 3, 4 or 5, and after 5 it cannot go, it has reached its limit. So we will get 1, 2 or A1, A2, 1, 3 or A1, A3, 1, 4 or A1, A4, 1, 5 or A1, A5. So this went with 1. And if we do it 2, then we will get here 3, 4 and 5. So we can say that A2, A3, A2, A4, A2, A5, and similarly if we choose here 4, then it should be 5, then A4, A5. So like this, if we continue doing, then we will get our required answer. So like this we can solve combinations. It is not limited to only 2 figures, two combinations. We can also select odd object combinations. For example, 3 object combinations if we want to do, then we have to count. In geometric approach we have to count the number of triangles, but in this approach we have to only solve the equations. That is, one more extra variable will be added, and using this variable we have to solve this equation. Then we can identify the possible results, or we can calculate, or we can count the triangles, and we can do it. So that was all about combinations. But for permutations, previously I have told that this method of permutation, where we swap the variables, this method is valid mostly for permutations when we take all the objects or all the letters at a time. But if we do not take all the letters at a time, if we take all letters at a time, then the method is slightly different. Then we use this formula, that is NPR equal to NCR into R factorial. For example, in the set A, B, C, D, if I want to do the permutations by taking 3 at a time. So first I have to tell the combinations that I will get by taking 3 at a time. Then I will jump on to the next thing, that I have to rearrange it. So if I rewrite this thing A1, A2, A3, A4, and if I want to calculate the combinations that I will get, I have to take 3 at a time. So X, Y, Z, and Y must be greater than X and Z must be greater than Y. Minimum value is 1. It can be 2, it can be 3, 1, 3, 4, 1, 4, 5, it cannot go to 5. Then 2, 3, 4, 2, 4, 5, it cannot be 3, 4, 5. So these are our required answers. So this many permutations we can get of A, B, C, D. Total 3 combinations. Sorry, it is not permutation, it is combination. So this can be written as A1, A2, A3, A1, A3, A4, A2, A3, A4. Now what we have to do is we have to rearrange this to get our required answer, and the rearranging method is similar to this. That is, we have to swap it and total, and by swapping it, the answers that we'll get, we have to swap for each case. For this one we have to swap, for this one we have to swap, and for this one we have to swap. Then after doing all that, we will get the total number of permutations that we want. So that was the method.